All right, so here we are getting ready 5. And the beginning of the assignment here, we are looking at some relations and trying to determine whether or not they're functions. And then regardless of that answer, we can list or we can identify their domain and range. Okay. So in number 1, we have a set of points just listed. So what we have to do is check to see, are any of those x's assigned to more than one y value? Well, my x values are -7, 3, 8, -6, and -2. Since none of those repeat, none of them can be assigned to more than one y value. So yes, this is a function. Since it's just a list of points, I do the domain as a discrete function here. So the domain is the x values. That's -7, -6, -2, 3, and 8. The range values would be 2, 3, 4, and 5. 2, 3, 4, and 5. Now notice the 5 is in 2 of the points, but when you list the domain and range, you don't ever repeat the values. Doesn't matter how many times they're used, you're just listing everything that is used. Okay, and number 2, my x values I have, maybe I could just do my domain as I'm looking at these. So the x values are from least to greatest, 0, 2, 3, 4, 5, and 9. 3, 4, 5, and 9. So that's 6 values, but I have 1, 2, 3, 4, 5, 6, 7 points. So what I'm seeing is this point 0, 4 and 0, -3, they use the same x value, 0, but it's assigned to 2 different y values. It's assigned to 4, and then it's assigned to -3. So this one is not a function. The range would mean the y values. So what's used here? We have -3, we have 0, 1, 2, 3, 4, and 7. Number 3, I have just 4 separate points. 1, 2, 3, 4 are my x values. Since none of them are repeated, none of them can be assigned to multiple y values. So yes, this is a function. The domain would be 1, 2, 3, 4. Now the reason I can't just say it's 1 through 4 is because that would imply that 1.5 and 2.7 and 3.1 and 2 2/3 are all part of the domain also, and they are not. This is a discrete listing. So the range value is 0, 4, 7, and 9. Okay, number 4, we are looking at a graph. Doesn't matter what kind of graph that is. It's just a curve as far as you know right now. And we're going to try to identify the domain and range. Now, the domain is the x values. The furthest point to the left here on the graph occurs at 1, but there is no rightmost point. This arrow implies that continues to the right. So my domain values are every x greater than or equal to 1. I chose to put the or equal because there is a solid point when x is 1. The range values now, the y values, the lowest one happens here at 0, and then it continues to increase. Now it's hard for you to tell probably how far that goes. Does it level off at 1? I believe that is supposed to show that it is slightly, slowly increasing. So I would say that the range value would be all f of x is everything greater than or equal to 0. Okay, number 5, my domain. Again, this is not a continuous function like number 4, so I'm just going to have to list the domain elements and range elements. Domain elements are -1, 0, 3, and 7. Range elements, -4, 3, 12, and 29. The number 6, all I'm given is an equation. No points, no graph, no table. So if I think about what sort of equation I'm looking at, that's in the form a times b to the x. It's an exponential function. All right, so that should help a lot. I know that 3 is the y-intercept, and it multiplies by 5. So the graph would look something like this. It would be increasing, very steep. The y-intercept here is at 3, and then it multiplies by 5. This left side, if you recall, on an exponential graph, is infinitely close to the x-axis, but we'll never touch it. So the domain is all real numbers. The graph starts from negative infinity and continues to positive infinity. And the range, though, goes only the positive values. Everything above the x-axis. So g of x can be everything greater than 0. Okay, now we are trying to determine if these situations are functions or not. Okay, so again, the definition of a function is each element of the domain is paired with exactly one element of the range. If we read these as if the first variable introduced is the x and the second variable introduced is the y, that would mean the person's name in number 7 is your x value and their phone number the y value. So if you read it forward like that, x then y, does a person's name get paired to only one phone number? Well, no, I don't believe it does. A person might have 2 numbers. They might have 3 numbers. I have a work number and a cell number, so that would not be a function. Okay? A person's name can be paired with more than one phone number. Okay. How about number 8, the stadium that a football player is playing in related to the outcome, meaning win, lose, or tie? Does every stadium get paired with exactly one outcome? Well, again, I don't believe so. A team could play in a stadium and win one week. The next week, they could play in the same place and lose. So 2 different outcomes. So a stadium or location for a game can be paired with multiple, more than one outcomes. Number 9, school's mascot and the location of the school. Think of that as our mascot is the Bears. Is having the school mascot be a bear, is that assigned to just one location of a school? Does every bear assigned to Briggs Cheney Middle School? And the answer, of course not. So no, that one's not a function either. A mascot can be paired with many schools, many locations. And our last part here at number 10. Now when you read through that little scenario, it does not mention, we can tell that the formula has D for distance and T for time, but it does not tell us how we're measuring the distance or how we're measuring the time. Now, when I get down to question D, it does mention miles. So I guess our distance is in miles. So I'll just assume that T is that the time is in hours, okay? So let's make that assumption that T is hours and D is miles. Okay. So what would Hope be attempting to find if she writes D of 4 equals 78 times 4? Well, what she's done there is just replace the T in both sides of the equation there with a 4. So that means she's considering T, the value of T, to be 4. So she's finding the distance traveled in 4 hours. Okay, and 78 times 4 is 312 would be the answer. So that would mean the family traveled 312 miles in 4 hours. Okay. Part B, what would D of T equals 450 mean in this situation? Now what we've done here is replace the entire right side with 450. Well, that means the distance is 450. The time is what is unknown. So it means the distance traveled in T hours is 450 miles. And we do not have the number of hours. We could solve for it, weren't asked to, but that's what it stands for, is the distance was 450 miles, how many hours? Part C, what would D of 3.5 mean in this situation? Well, again, now since it's D of 3.5, the number in the parentheses, 3.5, that means it's the T value. So it means the distance traveled in 3.5 hours. Again, we don't know that without doing a little more math, but if we wanted to find that value, we would just multiply 78 times the 3.5. And lastly, part D, how could Hope use the function to find the time it would take to travel 800 miles? Well, since 800 miles is the D in the problem, it means we want to replace D of T with 800. So 800 equals 78 T. And then to solve that, we would just divide both sides by 78. So 800 divided by 78 is, it's 10.256, blah, blah, blah. So it's still a rational number. We do not want to round that. It's approximately 10.2, but if we just simplified this fraction, it would be 400 over 39, which is another exact way to write that would be 10 and 10/39 hours. Now the question actually said, how could Hope use that? I actually went through the process of solving for it, but you could have just answered that to say, Hope could replace D of T with 800, then solve for T.